Today's wireless-enabled designs often feature complex RF signals that can vary significantly with time. Analyzing changes in your RF signal is a necessary yet challenging task. The MDO4000 series of mixed-domain oscilloscopes makes visualizing your design easy with its time-correlated view of analog, digital, and RF signals. For easy analysis, there are 3 ways to view RF activity relative to your time domain signals. The amplitude versus time trace shows how the amplitude of the RF input is changing over time and is shown in dBm. Frequency versus time indicates the instantaneous frequency of the RF input relative to center frequency and shows changes over time. Phase versus time shows the instantaneous phase of the RF input relative to center frequency phase. Since these traces are displayed in the upper window, this makes it easy to time correlate your RF signal with your analog and digital signals. Let's look at a few examples. The first example is a frequency hopping signal. Here is a setup. The RF signal is connected directly to the oscilloscope's RF input. Channel 1 is connected to a pulse that's used to trigger and synchronize the acquisition. The bottom display is the spectrum of the RF input. The data used to calculate the spectrum was taken from the time period indicated by the orange bar, called spectrum time. By moving the wave inspector control, you can see how your RF spectrum changes over time. Here you can see the spectrum of the device is hopping as expected. Instead of scrolling through the entire record to view how the RF signal changes, you can add a frequency versus time trace to easily see frequency changes. As you can see, this signal has lots of overshoot and may not meet the settling time requirement. Now let's look at an example of a phase lock loop. Here a command to change frequency has been sent over the SPI bus. The voltage-controlled oscillator or VCO-enabled signal goes high and the VCO begins changing frequency. By scrolling through the acquisition, you can see the RF spectrum is changing over time as a VCO moves to the new frequency. Now a frequency versus time trace is added to enable fast and easy timing measurements of the PLL. By simply using cursors, you can accurately measure the time delay. Then a simple rise time measurement can be made on the VCO's RF output to measure the settling time. With the MDO's unique ability to capture time-correlated analog, digital, and RF signals, you have complete system visibility. And with the amplitude, frequency, and phase versus time traces, characterizing your RF signal has never been easier.